These are the notes over section 4, which is factoring polynomials for Algebra 2. So I think these steps right here are very helpful to just kind of focus on. So always start with looking for a GCF. So is there a greatest common factor you can factor out? Begin there. Then look and determine, okay, is there a special pattern? Is it a trinomial? Or are there 4 terms? Look for those types of things. And then treat it like a quadratic. We'll kind of see that one as we go. Okay, when it is factored completely is when it can no longer be factored any further. So let's kind of focus on example 1 here. Factor each polynomial completely. So I see that every single one of these has an x. So an x can come out of all of this. It can come out of x cubed, x squared, and x. Now there's not a number that can come out because this is a 1 right here, and 4, and a 5, and there's not a number that divides into 1, 4, and 5 other than just a 1. So we're going to divide everything by x. So some teachers will show it with one large division line. I like to show each thing being divided by x because that lets me know I need to simplify every single term. So I have here x cubed divided by x, and so that makes x squared. And then here I have negative 4x squared divided by x. That makes it negative 4x. And then last I have negative 5x divided by x, and that makes that negative 5. So you need to go ahead and write the x out in front of the parentheses. You don't just leave it out because what you're doing is you're factoring it out in front. And you know what? This might factor further. I better not mix that in. So you leave it in front. And if you want to make sure you're doing it right, if you distribute x times x squared, you get x cubed. X times negative 4x is negative 4x squared. X times negative 5 is negative 5x. That's how I know that I've done it right so far. So now in here, in this parentheses, this is a trinomial. That means there's 3 terms. And typically those will factor further. So let's take a look. It would multiply to AC, which is negative 5, and it has to add to negative 4. And so that would be negative 5 and 1 that multiplies to negative 5 and adds to negative 4. So we still have this x right here in front. That's not going away. But this highlighted portion factors into x minus 5 times x plus 1. And now that is fully factored, and that's what our solution is. Okay, let's look at another one. So like on this one, 3y to the 5th minus 48y cubed. So a y cubed can come out of both of those things. So I'm going to pull a y cubed out. And then let's see, 3 is this coefficient. Does 3 go into 48? Yes, it does. So I can pull out not just a 3, but a 3y cubed out of everything. Okay, so that comes out in front. And what's left goes in the parentheses. So if I look at what's left, I do 3y to the 5th divided by 3y cubed. That leaves y squared. And what happens is when you do y to the 5th over y cubed, what you're basically doing is it's like you have 5 y's up here and 3 y's down here. 3 of them cancel out, and that's why you're left with 2 y's up top, which is y squared. Another way to do that is to subtract the powers. 5 minus 3 leaves y to the 2nd power. That's from Algebra 1. Okay, on the second part, negative 48 divided by 3 is negative 16, and y cubed over y cubed cancels out. So now this is not quite done yet. If you notice this part right here in the parentheses, this has a special pattern. That is a difference of squares. Out, you square root the y squared, you get y. You square root the 16, you get 4. So you have y plus 4, y minus 4, and don't forget, you still need to have that 3y cubed out in front. Don't forget to write that as part of your answer. And that is fully factored. Okay, Let's take a look at C. So looking at this, I have z to the fourth, z cubed, and z squared. So I can pull a z squared out of everything. And then looking at the numbers, I have a 5, a 30, and a 45. All of those are divisible by 5. That's the GCF. So I'm going to pull out a 5z squared out of everything. So when I do that, you are factoring it out. So you're like undoing multiplications. You're kind of dividing it. It doesn't go away though. It ends up in front of the parentheses. So 5z to the fourth, divide by 5z squared. The 5's cancel out. Z to the fourth over z squared is z squared. What I'm doing is I'm subtracting the powers. 4 minus 2 leaves a power of 2. Now 30 divided by 5 is 6, so it's plus 6. Z cubed over z squared is z. 45 divided by 5 is 9. Z squared over z squared simplifies out. Okay, and then looking at this, you always got to look and be like, can anything else come out? This factors further. So this is a trinomial. So that's the what multiplies to AC adds to B thing. So it multiplies to 9. It adds to 6. So that would be 3 and 3. So I still have 5z squared out here, but then I have z plus 3 times z plus 3. And you can leave it like that, or since z plus 3 times z plus 3 is the same thing, you could also write z plus 3 squared. I don't really care. These are the same thing. You can write it either way. So here's just some notes of some of the special formulas. So if you recognize that something is a sum of 2 cubes, here's the formula to do so. And a difference of 2 cubes, here is the formula to do so. I would very heavily recommend that you kind of make a note. I would definitely put these two on note card. So like I'm making note to myself. So if I do this as I'm taking notes, when it's time to build a note card for the test, I'm like, okay, you better go back and write that down. So let's see what that means. Okay, looking at this, I recognize first that I have x cubed and it's subtracting. So I know I'm going to use difference of 2 cubes. And then this 125, I want to write as a number being cubed. So 125 is the same as 5 cubed, or 5 to the third power. Now I'm going to go ahead and just copy the formula for the difference of cubes that we just had said to write in a note card. So I'm going to go ahead and see if I do that better. Copy that down right here so that I just have it in front of me and I'm not having to scroll for you. So it's the one that I had just put in a box and said, hey, put this on your note card. All right. Okay, so when we do this, here's what we do. This is A. A is whatever is being cubed right here. So in our case, the X is wherever we see A, we're going to use X. We're going to use it right here. And then, see if I can do this, wherever we see B, that's this. B is not 125. B is the 5. It's the number being cubed. So 5 cubed is 125, so 5 is B. So wherever we see B, we're going to use that 5. Okay, let's see if we can follow this format. So you start with A minus B. Remember, A is the X minus B is the 5. All right, now let's do the second parentheses. You start with A squared. A is X, so X squared. Plus, you do A times B, so X times 5. Are you guys okay if we write that as instead of X times 5, it would make more sense to put 5X, which is perfectly fine, but makes a lot more sense. And then plus B squared. But instead of 5 squared, think that through, 5 squared is 5 times 5. So we're going to go ahead and simplify that and put 25. And that is our factored form. And then the x squared plus 5x plus 25 doesn't factor further because there's nothing that multiplies to 25 and adds to 5. Okay, let's try another one like that. So on this one doesn't look like difference or sum of cubes at first. Let's factor out a GCF and see what this could be. So they're both even. I think they both divide by 2, and then they have s to the 5th and s squared. So we're going to take out 2s squared and see it. I'm pretty sure that's the GCF. I think 2 is the biggest number that goes into 16 and 54. So 16 divided by 2 is 8, so that's 8s cubed, plus 54 divided by 2 is 27, and s squared and s squared cancel out. So this 2s squared is right here, and then I'm going to factor out this inside the parentheses. This is sum of cubes. Okay, how I know this is sum of cubes. Hopefully you will get better as we go of just being able to recognize when something is a number that is cubed. So you could even just write down 2 cubed is 8, 3 cubes, 27, 4 cubed is 64, 5 cubed is 125, 6 cubed, I'm pretty sure is 216, and so on. But there's just some that you could recognize. So when I see 8s cubed, what that is that is the same as 2s being cubed, and instead of 27, that's the same as 3 being cubed. So this is my A, this is my B. So here's your B right here, it's 3. Your A is 2s. Okay, so we're going to follow the pattern. All right, the pattern I don't necessarily have memorized. I'm going to write it down. Sum of cubes, it's the one we boxed in. I'm just going to write it down real quick so I can see it right in front of me. Okay, so you do A plus B. A is 2s plus B is 3. Then you do A squared. So A is 2s, and when you square it, that makes 4s squared. All right, and then you do minus A times B. Well, so it's 2s times 3. Well, 2s times 3 makes minus 6s. And then it's plus B squared. Well, B squared, 3 squared is 9. So it's plus 9. And so this right here is our answer, this whole thing.